Hi, I'm going to work through this problem for you here. This was the Module 4 discussion question. So we're supposed to answer the following questions based on this information that's given to us up above here. So I'm going to start by reading through this description of the situation and then look at the questions. So it says, a devastating freeze in California's Central Valley in January 2007 wiped out approximately 75% of the state's citrus crop. That sentence is information, background information, helps us to get set into the scenario. Then we read on. It turns out that the cost for a box of oranges is a function of the percentage of the citrus crop that was frozen, i.e., C is equal to G at P, where C is the price of a box of oranges and P is the percentage of the citrus crop that was frozen. There's a lot packed into that sentence right there. I'm going to highlight that sentence right where it says out, starting here. The cost for a box of oranges is a function of the percentage of the citrus crop that was frozen. Let me see if I get a smaller pen here. There we go. All right, so then we go to further information. When 20% of the crop was frozen, the price for a box of oranges was $11.58. However, the price per box was $25.32 when 80% of the crop was frozen. Okay, so what's going on here is we have a function. We're told we have a function. We're told we have a function where the cost of the box of oranges is a function of the percentage of the citrus crop that was frozen. If I were to draw out a function, sorry, all my settings are a little bit messed up here. So let me erase this. If I were to draw out an illustration of a function, and in this case, I'm going to call the function g, and I want to know what is my input and my output of my function here. I'm going to read this. It says the cost for a box of oranges is a function of the percentage. In other words, the cost of the box of oranges is dependent on the percentage of the crop that was frozen. So the percentage of the crop that was frozen is the input into my function, and the cost of a box of oranges. And we have to be specific here. We have to say the units. The units is in dollars. So the cost of a box of oranges in dollars is the output of my function. We get all of that from that one sentence, but we also get it when we look at this statement right here. C is equal to G evaluated at P. So now I'm going to come over here. So in other words, P is my input. That's the percentage of the crop that was frozen. And C is my output. And so with function notation, since the name of my function is G, this is telling me that the output is a function of the input. So this is great review for the exam. All of this was covered back in Module 2, where we talked about what is a quantity and what is function notation and how do we read function notation. So when it says identify the input quantity, it's not looking for a specific number. It's looking for something that you can assign a value to. So quantity here is, for the input, is the percent. So I'm going to write that here. A, the input, is the percent of the citrus crop that was frozen. And then B is identify the output, and the output is the cost of a box of oranges in dollars. Be very specific when you're stating what your quantities are. Now, from here, we could make a table. It's really handy oftentimes to have a table of our data. And so then we would say, all right, then P is my input, C is my output. And then the very next sentence gives us some information about particular inputs and outputs. So we know 20% of the crop was frozen. The price was $11.58. So I can put the 20 here. I don't have to write that as 0.2. 20 is the percentage, and we've identified our input as the percentage of the citrus crop that was frozen. So 20 is that percentage. And the cost is $11.58. When I read on, I find out that I have a cost of $25.32 when my input is 80. So when 80% of the crop is frozen. All right. Then we move on to C. C says, using the method demonstrated in Module 3 presentation, create a formula for a linear function that represents this situation. In other words, your formula should use one of these given reference points rather than the vertical intercept. So I'm not looking for the y equals mx plus b form here. That's actually in the next step. In this case, we're looking for the method demonstrated in Module 3. And in Module 3, we learned that y is equal to the CROC multiplied by the change in our input, x minus x ref. Add that to where you're currently at. So in other words, I don't need to go back and find out when 0% of the crop was frozen, what is my cost? I don't need to know that in order to create this formula. I can start at P equal 20 and I can just move from there. And that's what we spent Module 3 reviewing, was developing this formula here for a linear function. And so, well, I see I have two different reference points I can use. It doesn't matter which one I use, but I see that I need to determine the CROC, and it actually gives you a hint. You will first need to find the constant rate of change. So let's do that. Let's find the constant rate of change. We have 2 points. So when you have 2 points, you find the constant rate of change by finding the change in the outputs divided by the change in the inputs. So in this case, the change in my outputs is equal to 2532 minus 1158, and that's over 80 minus 20. So I'm going to plug that in real fast. And 25.32 minus 11.58 gives me 1374 over 60, which equals 0.229. So that's my constant rate of change. This is telling me what? That the cost of the box of oranges increases by $0.229 every 1% for every 1% increase in the percent of the crop frozen. So now I'm going to take that and create my formula with that. So let me come back over here, and I say then, in this case, I'm going to use the proper variables for the situation. So I will say cost is equal to 0.229 times, not x, sorry about that. I don't have x defined here. I have p. P minus p ref, I'll use the 20, plus 11.58. It didn't matter which formula you wanted to, which reference point you wanted to use. You could write the formula like this: 0.229 p minus 80 plus 25.32. All right, so that takes care of part C. Part D says to rewrite this equation so that it's in the y equals mx plus b format. You can do that by distributing. You could distribute this across the p and across the 80 and then simplify. Or you can plug in 0 into the p-value to find the corresponding output when the percent frozen is 0. So I'm going to do it that way. I'm going to plug in 0 into my equation, and when I do that, I find the cost at 0 is equal to 0.229 p minus, 0 minus 20 plus 11.58. So that equals 0.229 times negative 20 is negative 4.58, which I have to add to 11.58, which gives me 7. So I do know now that my cost when 0% of the crop is frozen will be $7 per box of oranges. So I am going to rewrite my formula now because that's what Part D asked me to do. And so I will come up with the equation C equals, the CROC is still 0.229 times P plus 7. So either one of these is using one of the reference points other than the vertical intercept. If we want to use the reference point that is the vertical intercept, then we have this formula. Okay, so the next two questions are to identify the practical domain of the function and the practical range, and to explain your reasoning, why you chose these values. So a practical domain and a practical range is asking for the inputs and the outputs that make sense in the given situation. So in our given situation, we're talking about inputs that are representing the percent of the citrus crop that was frozen. And so if you think about it, you can't have more than 0% of the crop frozen. You could have 0% of the crop frozen. You could have a really great year where there's no frost at all. And so you could have 0% of your crop frozen. So I will say 0 is less than or equal to P. Now, the most crop that you can have frozen would be 100%. You can't freeze more than 100% of what you have. So if you freeze 100% of your crop, you've lost all your crop. Now, it's interesting to point out that if you lose all your crop, then of course you don't have any oranges to sell. And so the formulas that we created here would be nonsensical because there would be no cost if there are no oranges. So I'm going to say is less than 100. I'm not going to include the 100 just for that reason, that if I truly did sell, have 100% of my crop frozen, I would have no oranges to sell. And so that's my reasoning why I chose that for my domain. Some of you use the 20 and the 80 for your domain, and so you said 20 is less than or equal to P, less than or equal to 80. And you could argue that that might be reasonable. You could argue that it might be impossible to ever have a crop where at least part of it wasn't frozen, justifying your 20. And you could say, well, maybe it's possible where you never ever would lose 80%, more than 80% of your crop, and that would justify your 80. But you can't just use 20 and 80 because those were the given values. What if I'd have given you 20 and 50? It's clear that it's easy to lose more than 50% of your crop. So when you're picking your domain, pick values that make sense for the situation and then justify why they make sense. Okay, so now I'm going to talk about the range. And the range are all the outputs. So remember, we have this function right up here, we have this function where we're taking the percent of the crop frozen, and then the function will determine the cost of the price of oranges. So our output is dependent on our input. My input values can only go between 0 and 100, so I need to find the corresponding output values that match that. Now, we already found out that if 0% of my crop was frozen, that the cost of the box of oranges would be $7. And so it turns out that 7 is the lowest that my cost would ever be. Okay, well, what if I go, up to that 100, up to but not including that 100? Then what would my corresponding cost for the oranges be? And when I look at that, so I'm going to put 100 in my table here and find out the cost. And I'm going to use any one of my 3 formulas that I have here, and I'll just plug in P is equal to 100. So I'll use this last one because it's in its most simplified form. So 0.229 times 100 plus 7 is going to give me $29.90. So that would be the maximum that the box of oranges would ever cost. And the reasoning behind that is because these output values match these input values. Now, one hint I want to tell you is that if you're ever being asked for practical domain and range, do not include infinity. Infinity is never practical. Nobody can ever reach infinity. All right, so now I'm going to continue on to talk about the last 3, which are all dealing with the inverse. So the first question, G, asks us to identify the meaning of the inverse of the function at 12. Now, the inverse function takes the original function and works backwards. So now what's going to happen in my inverse function, I'm going to try to pick a different color up here. So for my inverse function, my input is the cost of the box of oranges. And my output is the percentage of the crop that was frozen. It's just taking the original function and making it backwards so that what was the output is now the input, and what was the input before is now the output. So this 12 here is the input into the inverse function, which makes it cost. So that 12 is $12. However, this whole expression is not $12. That whole expression is equal to P. So we would say that the inverse of G at 12 is equal to the percent of the crop that was frozen when the cost for a box of oranges is $12. All right, then we need to find the formula for that and then evaluate it. So I want to leave all this here on the screen, so I'm not going to go to a new page. I'm going to kind of come up here and work up here. I'll stay in the green for now. So find the formula for P equals the inverse function of G at C. So I'm going to work with this formula right here, and I'm going to find what P equals. So I say, well, I need to take this formula and find out what does P equal, because P is my output, so I need to have a P equals. So the first thing I'm going to do is subtract 7. So C minus 7 equals 0.229P. Then I will divide both sides by 0.229, and I end up with C minus 7 over 0.229 equals P. That's my inverse formula. That is the inverse of G at C. I now have a function for P in terms of C. So when I want to evaluate the inverse function at 12, I plug in 12 for C. So I will say P equals 12 minus 7 over 0.229, which equals 21.83. And so that tells me that when the cost of my oranges, cost for a box of oranges is $12, then it must be that 21.83% of my crop was frozen. All right. Well,